evening. Awake or still sleepy? Okay. Hi everyone. I'm Dhaval Patel. I'm VP of Software Engineering at Infocusp Innovations. So today we will talking about Weather-Viz. So weather visualization. So what is weather visualization? Anyone? Why do we need weather visualization? Anyone? Yes.
Hello. For
Yeah.
heat mapping, sensing on which state we have hotter areas, we can map, we can track the rainfalls and all, and we can also check how the wind is flowing and where are the chances of cyclones and all.
Okay. Yeah, that is correct. So this is the today's agenda for session. So we will talk about the what inspire us to build this weather visualization app, then how we build it, how we data processed it, and so on. So next, before going to the next part, let's look into the how it looks. So this is the our demo where we have created the weather visualization. It includes the temperature. If we change it to the rainfall, then in some of the sections we expect the rainfalls. Then there is a wind, and so this is we can zoom in, zoom out, and so it will show us for the whole world as well as the particular section. So this is what we will learn how we can build this and how you can work with the geospatial data sets. So now coming back to the slides. So now let's talk about the inspirations. From where we thought about building this application. So before that, let's talk about the why weather is important. Anyone? So here we already know that why weather visualization is needed. But before that, why weather is important? Anyone wants to answer that? Or how weather is impacting the everyone? Anyone? Yes. Okay. Okay. So he mentioned regarding the farming. Anyone else, any other industry where weather is important? Anyone? Yes. Anyone else? Airlines, import export, cricket match. That's the, and even weather also impacts the our day-to-day life. So from the economy, public health, disaster planning, aviation, daily life, it weather impacts everywhere. So why weather is important for economic? So as a friend mentioned that the agriculture. So agriculture is the most, or the we can say a strong pillar for the economy of India. So it is very much important for India to have a good agriculture growth, and for that a good weather or the weather prediction is required. If we have the proper weather predictions, then the farmer can choose what crop to grow and so on. So for the same weather information, we get to know about them from the various uh, departments, from various sources. So this is the Indian Meteorological Department's website, which shows us how the rain is going to, or how rain pattern is going to for some particular period. So these kind of forecasts are day-to-day available, and so these are the real data. But what today we are talking about is weather forecasting, or the how the next 10 days gonna look like for us. So for that, we have there are many websites which give us which plots those things, and from that one of them is the Windy. So let's first look about what it is or what it gives. So this is the Windy. It has multiple uh, weather details like the weather radar, satellites, wind, rain, and also you can play. So how the weather is going to look like. So here you can say after every few hours it will change, or how it will impact throughout the days. So this is the one where temperature is constantly changing day and night. So during the night we have the low temperature, during the day we have the higher temperature. So for that every tile is changing. So this is our inspirations, or from here we have started looking into how we can also build similar presentation. So before coming to the implementation part, why weather visualization is hard. Let's talk about the scale of data we are processing, or we want to process for this kind of visualizations. So here we have the, let's consider we are talking about the 1 day of data. So which is 40 minutes in a day. And let's consider we are talking about the 0.25 spatial resolution. So what is it? We cover it later on. But this is the 721 multiplied by 1440 points. And in Windy, we have seen there are multiple values, whether it is a wind or temperature or precipitations and so on. So let's just, for the sake of the calculation, consider the 10 variables. And those are the floating values. So if we calculate those things, then it will come up to around a half an TB of the data per day. So those are the scale of the weather data which everyone who are in the weather system, they are processing daily. So what's the challenge here is turning this massive climate data set into clear and interactive insights. So let's, for implementing this, let's talk about how we can do that. So we are using the fully cloud-based applications for managing, processing, and visualizing the data. So as a source, we are using the Google's DeepMind WeatherNext dataset. We will talk about the dataset in detail next. Then we are processing it using the Dataflow pipelines, which is also a large-scale ETL pipeline which is distributed. So we can run it at large scale. Next, to store the data, we are using the Google Cloud Storage. Similarly, for the front end and back end, we are using the Cloud Run and Leaflet.js, which is a library which gives us the way to plot this kind of data which we earlier saw. And for the security part or for protecting the data, we are using some of the services from the GCP, which is the IAP, Cloud Armor, and so on. So how does the data flow look like? So we got the data from the WeatherNext, then we are ingesting it to the Dataflow pipeline, and we are transforming them and generating the output as a cloud storage. Now, those stored data we are serving using the Cloud Run, and it is displayed on the web browser. So let's talk about the WeatherNext data. So we have shown that the initially there are large data volume. So for our case, we don't able to process those much of data in-house or locally. But we have the some of the forecasting models which are generated by the Google DeepMind. That's called the WeatherNext datasets. So there are mainly two forecasting models, which is WeatherNext Graph and WeatherNext Gen. WeatherNext Graph is predicting 1 point for a given time, for a given position. Similar, but WeatherNext Gen is a ensemble model which generates the 50 points at a time. So we have the, there are main 4 parameters which are predicted by the datasets, which are the temperature, precipitation, wind, and sea level pressures. Those are stored in the ZAR format. ZAR is nothing but multi-dimensional arrays similar to ND arrays or the, but this can be chunked and accessed in the cloud native pipelines. Now, we have mentioned that the temperature, precipitation, wind, and sea. So temperature is nothing but what we observe day to day. Precipitation. So precipitation is not only rain, it covers these rain, snow, sleets, hail, or any kind of water which are coming from the environment to the surface. So in the same way, wind, in that I have written that the vectors. So why vector? Because wind has a direction. So it will move from the north to south or south to west or in any direction. So it requires a 2 component, which is U and V. So using those components, we at the runtime, we calculate the wind speed and display it on the demo. So now let's talk more about the WeatherNext dataset. So it has a so it gives the prediction every 6 hours or with the lead time of 10 days. So it is forecasting for the next 10 days of data. So let's say if WeatherNext has predicted the result today, then it will have the today's data for next 4 intervals as well as the same for the next 10 days. And spatial resolution of 0.25. So what does it mean? So in our Earth, we have the latitude and longitude. So if we consider the latitude from, so one latitude, we divide it, so data is for every 0.25 at latitude level as well as the longitude level. And as I mentioned that it has a single value per time per location. So let's say for one particular time, we have the temperature data for 12 AM, then same for same time, what would it would look like at 6 a.m. So here, from those data, we are considering these 4 data variables. So what it is? 2m temperature. So the temperature above surface level at 2 meter. So similarly for the precipitation, it's about 6 hours. And wind direction U and V component at 10 meter level. So we have mentioned the latitude and longitude. So we know Earth is a sphere. So those data is in the spherical portion. So how we can project them to the 2D world, because our displays are the 2D system. So it requires a 2D representation of the sphere. So for that, we are using the Mercator projections. So Mercator projections, how it works. So let's consider there is one source of light at the center of the Earth. It projects the, or we can draw the lines, and we project into the simple cylindrical projections. Then we flatten out that. So here, if you look into that on the top portion or the bottom portion, then you see that there are a disproportion. Why? Because from on the top side or the bottom side of sphere, we are expanding it to make it the 2D image. So anyone can spot the difference between these 2 images. So these images are taken from the Google Maps, but anyone can spot the difference. Anyone? Yeah. Yes. Yeah, so that's the one difference. Anyone else? Correct. So here we have the both images from the Google Map at different zoom level. So whenever, if you have used the Google Map, then initially it loads one particular frame. Then you can zoom in and zoom out. So based on that, whenever you zoom out, you start to lose some information. Why? Because the area covered by that becomes large. Then you cannot pinpoint the one place or very minute information. So as you zoom in, you get those details more. So here only the borders are visible for the state, but here you can see the internal network of the road network. It is also visible. So these are the different zoom levels. So so let's say we are at the zoom level 0. So zoom level 0 covers the whole world into one single frame. If we go to the next level, which is zoom level 1, then we divide the whole world into 2:1 sections horizontally and vertically. So that becomes the 4 total different tile. Next, if we go to the zoom level 2, then it will be 2:2 horizontally and vertically. So, and whatever the individual section we are creating, we are calling it a tile. So let's compute the how many tile we need whenever we are going or we are doing the zoom. So for 0, it's 1. For 2, it's 4. But if you go n, then it would be a 2:n multiplied by 2:n. In Google Map, if you have seen, there are you can go or click zoom in, zoom in, zoom in multiple times, around 18 to 20 times. So in that case, we have 2 raised to 20 multiplied by 2 raised to 20 images generated for that particular view. So how we can process those images? So for processing or for creating those images, we need to create first a base map, which is a static image which displays the world. Something like this. So it has a boundaries, either it is a coastline boundary or the state boundary. So it depends on the zoom level, at which zoom level we are, it has the different details. So base map, initially at zoom level 0, it only contains the coastline and country lines. Whenever we are going or increasing more higher zoom levels, then we will add state lines and different natural earth shape lines. So, and if we zoom in more, then we will add roads and those information. And also, we are using the GeoJSON map to compute the centroid of that particular location and projecting the name. So if you can see here, we have the India, Gujarat, Rajasthan. But if we are in the more zoom level, then in the Gujarat there is Surat, Jaipur. So those cities as well are highlighted. So now we have the static base map. So now what we need is a dynamic or the weather tile for each particular time. So that to calculate that, we required what information we have in particular tile. So if we talk about the tile, so let's consider this one tile. So it contains the data from here to here. So we need to capture those all the data which we have in the latitude and longitude form. We need to map that values here. And we need to use the different color maps for visualization purposes. And if also we need to do some kind of interpolation to make smooth image. So it is possible that we get the different values or the weather data where if there is one particular region in between the state, which is at a hill station kind of thing, then it has a lower temperature. But if we directly plot that, then it will become a pixelated images. So we interpolation of those data. Next, we talk about the rainfall values, which is a precipitation. So we are using the WeatherNet graph data, which is a prediction or the forecast generated using the models. So it may have some minor values like 0.001 millimeter of rain. So to don't make visual clutter on our final result, we are removing the data or removing the precipitation value which is less than 1 millimeter. So this is the sample for the rain precipitation as well as the temperature for one particular region. So this is the data flow execution where we are giving the input, then these R files are getting read then parsing, generating. So whatever I told, so this is the data flow diagram for that. So I have mentioned regarding the tiles. Usually those images are the 256 multiplied by 256, and those are generated at each zoom level. So here we have the three z, x, y dot png. So what it is? Z is a zoom level, and x and y is a particular location for your image. So if we tell that I want 3/3/ dot 0, then it will give me the image at zoom level 3 for a coordinate 3, 0. So which this is already we have covered that what is zoom in the zoom level. So this is the 0th tile. Then it has a minimum longitude and maximum longitude. Similarly, minimum latitude, maximum latitude. So entire world is divided in 2 raised to n multiplied by 2 raised to n zoom levels, and for computing the minimum and maximum longitude, we are using the same formula for for the Mercator's projections, and similarly for the to handle the distortions near the pole, we are also using the same formula for the latitudes. Sorry. So now I talked about the interpolation. So before interpolation, the image will look like something like this, which is pixelated. So to smooth that out, we are using the interpolation. So now, if you have seen the demo, in that at every time, it is whenever we are going from the, let's say, 12 hours to 6 hours, it is changing the layers. So how it is doing? Or if we change from the temperature to rain, then, so as I mentioned, everything is a PNG or the data in the form of PNG. So what it will do, it will first fetch the data from the backend regarding the next image, it puts it there, and then removes the front layer. So in the same will happen in the time layer as well, and it gives, or it will use some sort of delay for removing the front, because it is possible that if you have the slower internet or the you are getting slow response from the server, then you are getting late new tiles. So to handle that, it is getting removed after some time. So similarly, if we click on the one particular location, we can get the exact information about the what is happening at that location, or what's the temperature, what is the precipitation values are possible. So how we can do that? So to do that, we already have the zip JSON metadata files for every latitude and longitude. So whenever we have generated the tiles, we are storing those data along metadata in the zip JSON file, and we fetch them, and using those zip data file, we are generating the value of one particular location. So next, talk about the wind. So let anyone can tell me why wind is different, or the plotting the wind is different from the temperature? Yes. Correct. display, and based on the value of those particles which you have provided in the form of lat long, and whatever the value of u and v we have provided, it scatters them or it sends or move them. So here you can see that the particles are moving in one particle. If we talk about this particular particle, then it is moving this side. Different particles moving different side. So this will together combines the flow of the wind, and it gives us the visual representation of the from where wind is moving from which direction. So coming to hosting this whole application from where we have hosted. So as I mentioned, we have the front end as a leaflet module, which is hosted as a serverless application in the web app. Serverless web app on the Google Cloud Run that displays the weather tile maps, which we fetch from the backend using the Cloud Run, and those data is stored in the Google storage. So Google Cloud Run will interact with the Google storage, and it will fetch the tiles and serve. So for the storing the image or the Dockerized image, we are using the artifact registry, which has which help us to load the Cloud Run image. Now let's talk about why we choose Cloud Run and not other Google application. Can anyone tell me about that? So why we have chosen the Cloud Run? Or why one should use the Cloud Run for this application? Yes? Yes, easy to deploy. Anyone else? Anyone else? Okay. So Cloud Run, as friend mentioned, that it is easy to deploy. Along with that, it provides the auto scalability because it is a serverless in nature. So Google Cloud manages the auto scaling going from 0 to n number of ports and scaling back to the 0 whenever the demand is not there. So it helps the application to reduce the cost. And for the security, we are using the IAP to protect or to allow only the authorized user to access that. And similarly, Cloud Armor is there to prevent the DDoS attack and so on. Thank you. Anyone has question?